Welcome to today's lesson. We are going to look at length, and we start by defining the term length. Length refers to the distance between 2 points. For example, we have breadth, diameter, height, depth, and if you look at this, it means that, or it implies that when you take any 2 points and then you get the distance, then you are referring to the length, which implies that even the radius is a length, the height, the depth. The SI unit of length is meters and the symbol is small m. 1 meter is the distance between 2 marks on a standard platinum iridium bar that is kept at a constant temperature. So which implies that the meter rule that we use here in our country or in our school was measured using this bar. It is kept at a constant temperature to avoid the change of distance. Then we move to conversion of units of length. We have the multiples and sub-multiples of length as tabulated below. We have 1 kilometer is equivalent to 1,000 meters. 1 hectometer is equivalent to 100 meters. 1 decameter is equivalent to 10 meters. And as you can see, you can be able to get any equivalent as you want. But we want to use those equivalents so that we can be able to express or to convert the units of length. So we look at an example. Example 1. You're supposed to express the following in meters. The first case you have 0.006 micrometers. In the second case you have 7,000 kilometers. And then the third we have 10 hectometer. How do you go about it? We always start by writing the equivalent. 1 meter is equivalent to 1 million micrometer as it is indicated on the table. Then we want to know how many meters are there in 0.006 micrometers. You write the units that are similar on one side, the way I've done. I have meters on this side and I have micrometers on this other side. Then cross multiply. After cross multiplication, we have x is being multiplied by 1 million micrometer is on one side. Then it is equals to 1 meter multiplied by 0.06 micrometers as it is on this other side. Then we want to make this x the subject, or we want to be left with the x on this side, and we are multiplying, so we do the opposite. The opposite of multiplication is division, so you divide both sides. This will go and you will be left with x on this side, and then you have 1 meter multiplied by 0.06 micrometer, and then you divide by 1 million. Then from there you have to show us the units are cancelling out, so that finally you can be able to show where the final unit is coming from. So we have micrometer and micrometer have cancelled, so we are left with meter. So you just divide 0.006 divided by 1 million. You get this as your value in meters. Note that the symbol is small m. Then the second case, we have 1 kilometer is equivalent to 1,000 meters. Again, make sure that the units that are similar are on one side, then you cross multiply. After cross multiplication, we have 1 kilometer times x, that's what we have on this side. Then we have 7,000 multiplied by 1,000. And now to get x, I've said that because we are multiplying, we do the opposite, which is division. So you divide by 1 kilometer. Again, the units will cancel out, kilometer by kilometer. So you are left with the meter. So after multiplying 7,000 and 1,000, you get 7 million. The symbol is m, small m. Then finally we go to 10 hectometer. Again, we start by writing the equivalent, which is 1 hectometer is equivalent to 100 meters. Then you write 10 hectometer. Your x is on this side, remember. The units that are similar should be on one side. Then cross multiply. After cross multiplication, then cancel the units that are similar so that you are left with what you want. So finally you multiply 10 by 100, you get 1,000 meters. Then we move to measuring instrument of length. We have two methods that are used in measurement of length. We can measure length by estimation, or we can use accurate measuring instrument. We can measure accurately using suitable measuring instrument. Examples of instruments that are used in measuring length are: one, we have meter rule, and in our labs we always have half meter rule, so we can either use it depending on the size of the object that you want to measure. Then we have the tape measure, we have the vernier calipers. Vernier calipers are used to measure short length. For example, you want to measure the thickness of your exercise book, or thickness of the textbook, or thickness or the diameter of a measuring cylinder in the lab. You can use vernier calipers. Then we have micrometer screw gauge. This one is used to measure very short length. For instance, you can use it to measure the thickness of your hair, or the thickness of the wire that we use in the lab. Then we move to the factors considered when choosing an instrument for measuring length. One of the factors is that you have to consider the size of the object. For instance, if you are measuring the thickness of the wire, you don't need to go to looking for a tape measure. We have said that if you want to measure those small distances, there are those instruments like vernier calipers and micrometer screw gauge. So the size of the object determines the choice of your instrument. Then we have the level of accuracy required. We start by the meter rule. Now we have either 1 meter rule or half meter rule, and these ones are always graduated in centimeter or millimeter scale. Actually, if you look at 15 centimeter rule that you have in your geometrical set, it has both centimeter and millimeter scale. The smallest division on a meter rule, or the smallest division that can be measured using a meter rule, is equivalent to 1 millimeter. And 1 millimeter is the same as 0.1 centimeter or 0.001 meters. Now, this smallest division is what we call the accuracy. So we define the term accuracy as the smallest value that can be accurately obtained using the instrument. So in this case, for a meter rule, the accuracy is 0.1 centimeter or 0.001 meter or 1 millimeter, depending on the units that you are using. Then we move to the measurement taken using the measuring instrument. We have talked about the accuracy of measuring instrument. This accuracy will help us to know the number of decimal places that will be indicated when you are recording your value. For instance, if you are using a meter rule, we have seen that if you are using centimeter, the accuracy is 0.1. So it implies that the readings that you are getting from a meter rule should be to 1 decimal place if you are using in centimeters, because we have said that accuracy is the smallest unit that can be accurately measured using your measuring instrument. So it means for a meter rule, it is 0.1 centimeter. Therefore, we use 1 decimal place. But in some cases, you find that you can even go to the second decimal place if you are using a meter rule. But note that the second decimal place is approximated. You may have a case where maybe the pointer or where you want to measure is in between that millimeter mark. It is between that is 0.1 centimeter. So you approximate the second decimal. But remember, the accuracy is 0.1. For example, we have the readings that as 5.6 can be written as 5.60, or 6 centimeter can be written as 6.00. But we insist that the second decimal point or the second decimal place is approximated. Then we move to procedures followed when you are using a meter rule. Procedure number 1, place the meter rule in contact with the object whose length is to be measured. It should be in contact. Look at the diagram. The ruler and the object must be in contact. Then number 2, place the head of the object against the 0 mark of the scale. This is the head that has 0 mark. Ensure that it is aligned with the edge of the object that you are measuring. Then number 3, position your eye perpendicularly above the scale. Your eye should be here, the correct viewing. If you view it on this side, you get a wrong unit or a wrong reading. If you use it on this other side, again you get a wrong reading. And the error that we get because of not putting our eye perpendicularly is called the error due to parallax. So when we are using a meter rule, we may get an error due to 1, when the rule is not in contact with the object, and number 2, when the head of the object is not aligned to the 0 mark. This will also give you a wrong reading. And finally, if you don't position your eye perpendicularly to the scale, and this one I've said, this error is called parallax error. Error that occurs when the position of eye is not perpendicular to the scale. Precautions when you are using a meter rule. 1, take care of the edges of your ruler. If you look at your meter rule in your school or in your laboratory, you'll find that the scale starts at the edge. So when you damage the edges, then you interfere with the scale. And it implies that when you use it, you won't get the correct reading. Then we move to tape measure. We have 3 types of tape measure. We have tailor's tape measure, carpenter's tape measure, and surveyor's tape measure. Now, the choice of the tape measure to be used depends again on the nature and the length of distance to be measured. For instance, if you want to measure the length of your waist, you go for the tailor's tape measure. If you want to measure the perimeter of a plot, you go for the surveyor's tape measure. And if you want to measure a length of a piece of wood or a piece of timber, then you go for the carpenter's tape measure. So the nature and the length determines the type of the tape measure that you're going to use. Then precautions when you are using a tape measure. Make sure that it is tight, very straight. This will ensure that you get the correct reading. Then we move to measuring curved lengths. Sometimes you are in the class of geography and you're told to measure the length of a road in a map. How do you go about it? We say that for you to measure curved length, we can use a thread, and after using the thread, then you place the thread on a millimeter scale. You can either, you are supposed to mark the starting and the end point, and then you place it on a millimeter scale, and that way you are able to get the length of that curved length. We can use an experiment to illustrate that. You want to get the diameter or the circumference of a measuring cylinder, and we are going to use this as the apparatus. 1, we have 10 ml measuring cylinder, we have thread, we have meter rule. Then we move to procedure. Number 1, we are having you wrap closely a thin thread 10 times around your cylinder. This is your cylinder. You wrap it 10 times and make sure that the threads are closely, they are close to each other. Then you mark the beginning and you mark the end of the turn. Then after that, you remove the thread and measure the length between the ink marks. Remember, you have the millimeter scale, so you are measuring using the meter rule or any other measuring instrument. Then you call that R1. Then you repeat the procedure for accuracy. You repeat the second one, you call it R2. You repeat the third one, you call it R3. Then finally, get the average. And for us to get the average, we always add. We are going to add R1 plus R2 plus R3, then divided by 3. That way you are able to get the average. Then for us now to get, remember we wanted to get the circumference. So this one is our average. So the circumference will be r divided by the number of turns. We had made 10 turns, so you divide r by 10, you get the circumference. If you want to proceed to get the diameter, then you know that diameter is given by the circumference divided by pi. So that way, we are able to get the diameter, we are able to get the circumference of our curved measuring cylinder. Then we move to estimation of length. And to estimate length, we have another experiment. We want to estimate a very big tree in our school compound. So procedure number 1, we have that hold the rod upright and measure its length. Then measure the length of its shadow. You have measured the rod that is upright and you have measured the length of the shadow. Then measure the length of the shadow of the tree. This tree is in our school compound and we have this as our diagram. You have the rod, you have measured the height of the rod, you have measured the length of the shadow of the rod, you have the tree, this is the height that you want to estimate, but you have the shadow. You can measure the length of the shadow. Then after that, you use this expression to get the height. You have that height of the tree divided by height of the rod is equals to length of shadow of the tree divided by length of the shadow of the rod, which implies you have measured length of the rod, you have measured length of the shadow of the tree, and you have measured the length of the shadow of the rod. So we have the height of the tree as unknown, so you can be able to get it. So we look at an example. In an experiment to estimate the height of a tree in Mianzini Secondary School compound, John recorded the following data. 1. Length of the shadow of the tree was found to be 2000 centimeter. Length of the shadow of the rod 200 centimeter. Height of the rod 100 centimeter. Then you are supposed to determine the height of the tree. We apply the values in our formula or our expression. We have that height of the tree divided by the height of the rod, and these values, we always start with the formula and then we substitute. These values are given here. The height of the tree is x, is what we are looking for. The height of the rod is 100 centimeter. The length of the shadow of the tree is given 2000, and the length of the shadow of the rod is 200. So after cross multiplying, you can be able to get that x is 10.0 meters. Then we will have a quiz. Quiz yourself. Make sure that you calculate and get the correct answers. For the calculations, we are saying start by the formula, then substitute, and finally ensure that you write the correct symbol of the SI unit. Practice makes perfect. Ensure that you are able to get the correct answers. Thank you, and let us